Let's take a quick look at that quiz that I had you do. I gave you this quiz for a couple of reasons that I explained before. Let's talk about the answers and kind of what all that entails. Uh, if you went through it and you didn't answer every question correctly, that's fine. This is just really to see how you think, uh, your current aptitude for doing things. Doesn't mean you can't change that aptitude. Now, first off, I ask if you have any programming experience. And the reason for that is, well, if you do have programming experience, it can help greatly. I mean, a lot of programming languages are very similar. So basically, once you learn one language, let's say Java, you could easily convert over to C Sharp because they're just so similar. Now, there are some that are completely different. Let's say if we grab Ruby or, you know, some other language completely Visual Basic, there would be similarities, but there's going to be a lot of differences too. Now, if you're used to a language, it can also be hard to transition to another one sometimes. I've had people start writing in their old language they've learned, and they're like, "Why do I have all these errors?" Because they're not writing in Java. Every language is different. It's just like, speaking a different language. There's different syntax and ways to say things. If I was speaking French and then, I tried to speak English, uh, there might be the structure of how things work might be kind of similar. Uh, there we go. The structure might be kind of similar, but the exact way to say things would be a little different, depending. And there might be some sentences that are exactly the same. Depends on the language. So this can help you because if the structure, especially if the structure is very similar to what you've learned before, or it can hurt you if you have a hard time compartmentalizing, separating the different things that you know. But typically, once you've done a language or two, doing other languages and stuff is actually relatively easy because uh, syntax may be a little different, but structure is almost always the same, depending on what you're doing. Now, question two. Given the flowchart, what is number two's status? Well, number two is here. And if we just back up, we can pretty much figure out what they are. Uh, let's see here. We go here, and it looks like this is the path to get there. So, are they married? Yes. Do they have kids? Yes. Is it a male? No. So they're married with a girl, a female child, basically. Flowcharts can be used a lot in programming, especially if you have different decisions to make in a program or even a game or a story. Uh, and knowing how to follow them and get from place to place can be kind of useful. Uh, and this logic is kind of used in a program. Uh, if they're married, go to this. If they have kids, go to this. And it just splits and does different parts of the code. Now, given the following sentences, what is the proper order they should be in? Well, we have Alice is angry with Jim. Maybe Alice just hates Jim. I don't know. Jim apologizes to Alice. Okay. Uh, Jim jumps out from behind the wall, or behind a corner, and scares Alice. And then Jim decides to play a joke on Alice. So this is basically just what is the you think the proper order of this. Uh, so obviously Jim decides to play a joke on Alice, and that joke is to jump out from behind the wall. She gets mad about that, and then he has to apologize at the end. But I'm sure it was hilarious either way. DCAB. So this is just, you know, logical order of things. When you're writing a program, things have to happen in a certain order. If you write a program and they are not in that order, they're not going to do what you expect them to do, or it may not work at all. Uh, so whenever you're doing something, you have to start at the beginning and work your way down. You can't just jump ahead to the middle and skip all the preliminary stuff. It has to be done in a particular order. And this is just to kind of see if you kind of follow that. We got a little bit more, and we got a pattern. 0, 1, 5, 10, 11, and then 15 would be the next pattern. And the next one after that, if you were to look at this, so 0, 1, 5, 10, 11, 15 would be 20, 21, 25. In programming, in, well, math and lots of things, there's patterns. Knowing how to read patterns can be particularly useful, particularly in programming, because if you know that there's a pattern in of when you have to do a bunch of code, you can actually use that pattern and sometimes cut a bunch of stuff out. When we get to loops later on, a loop allows you to run a section of code over and over and over again. And if there's a pattern in your code where I write a whole bunch of things, I might be able to use that loop and instead of write 100 lines, write 5. And that's only if you can follow the pattern. Now, there's also problems where you have to do some math. And sometimes, if you know the pattern, it makes that a lot easier. Instead of having to write out a whole bunch of stuff, you just follow the pattern and you can do it a lot easier. So in math, in computer science, there's patterns. One of the famous patterns would be the Fibonacci sequence, if you ever heard of that. Basically, it exists everywhere, like literally beehives, pine cones, in nature. And it's just, if you want to Google it later, I'll probably talk about it again, but it's just a sequence of numbers that seems to be hard coded into just about everything. And knowing a sequence, can be particularly useful. Now, this is basically a little program outline. Now, what does it print? We start our program. We have A set to 5, B set to, or A set to 10, B set to 5. B is B plus 10. So what's 5 plus 10? That's 15. It should print 15. Now, we're not even using A. It's just printing B. So there you go. Now, the last little bit here is actually probably one of the more complicated ones, simply because there's this loop in here that basically keeps looping until a certain thing is true. So we have n is 0, and then we basically add 1 to it. So n is 2. And we ask the question, is n greater than or equal to 5? Well, 1 is not greater than or equal to 5, so we come here and we add 1 to it again. And we're going to keep doing this. 2, nope, 3, 4, 5. Once it hits 5, it's going to print 5. Just like that. Now, the last question is, again, kind of a mathy order of operations. You're not going to be doing a huge amount of math. It's one of the common misconceptions. People think programming requires all sorts of calculus and stuff. It doesn't. Honestly, you won't be doing much more than algebra a lot of the time. You'll be doing calculus if you were doing some graphic stuff maybe, or let's say building physics engines maybe. But for the most part, it's just mostly simple addition, subtraction, some algebra. Now, because computer science follows, the specific setup of how math works, a lot of people will, they'll do some math in a program and they'll be like, why isn't it putting out the answer I think it should? Well, a program will only do what you tell it to do. So in this case, if you look at this, it's going to follow the order of operations, which I think I've mentioned before. So the order of operations is basically this. If you remember PIMDAS, parentheses, exponents, multiplication, division, addition, subtraction, right? Please excuse my dear Aunt Sally. So if we look at this, if you just go straight down the list, you may end up getting the wrong answer here. Now, what happens first? This multiplication or these parentheses? Well, the parentheses does. So we go into the inner parentheses. 4 divided by 2 is 2. And then we come out, and now we have an outer parentheses. 2 divided by 2 is 1. So now we have 5 times 2 plus 1. Now, the multiplication is going to happen first before addition. If I did it the other way around, that would be 15. So 10, 11. And again, this is how math works. And it helps to know that because when you're, let's say, I order something in some program that I've built. I'll have a milkshake. 3 of them. And it does the math to figure out what the cost of that is and tells me. If my mental math is wrong, I may see the correct answer pop on the screen and be like, that's not right, and sit there for 3 hours trying to fix something that's not broken. Or if you don't do the math properly, it just may be broken the entire time. So it does help to know all that. And again, this is mostly just for my information so I can see how everybody thinks. If you didn't get everything right, that's fine. That's what this course is going to be teaching you about the entire time. It just kind of states whether it will be easier or a little more difficult for you to, you know, go through the course for the most part. If you made it through this fairly easily, then you have the aptitude to be all right doing programming. If you didn't, well, then you may have to work a little harder, but that doesn't mean you still can't do it. I've had plenty of people of all stripes and colors make it through the course with no problem. It just takes a bit of effort. And of course, if you have problems or anything like that, you ask questions. That's one of the big things. Always ask questions. I always, and I'll complain about this maybe once or twice more, but I'll give you this warning. I'll go ahead and give you this warning now. Uh, as you're going through the course and you're writing something, if there's something you don't understand, say something. Ask the question. Far too often, people will just sit there silently, particularly in a programming class. You know, they'll be like, well, I don't want to sound stupid because I don't understand this. If you don't ask a question, you're not going to understand it. The worst thing you can do is sit there and be like, well, I guess I'll figure it out later. Everything you're learning, you're going to have to use. If you don't understand something, that means you're going to basically fail at it when you try to do it later. If you ask a question, I will happily explain anything that you have a problem with. And I guarantee you there's at least half a dozen others who probably have the same question and want to be quiet too. So ask if you have a question. Doesn't matter if it's stupid. Who cares what people think? If you want to learn how to do it, you have to ask those questions. There's no such thing as really a stupid question. It's just if you don't know, ask and then you will know. Then you don't have to ask that question again. And hopefully you'll do better on the projects because of it. I've had more than a handful of people silently sit back and fail the first couple of projects because they wouldn't ask any questions. Then I go see them and I'm like, what's up? Well, I don't understand this. And I explain it to them and it clicks. And then, they could have saved themselves a ton of torment and points just by asking questions. So don't sit silently. You know, if you don't understand something, ask. And that's true for any class, not just for programming class. All right, well, that is basically the quick quiz. If you have any questions or anything, you again ask him.